Yes, once again, welcome to Easy Gates Gate 22 Instrumentation Paper Solutions. Next problem, question number 35, another analog electronics problem, simpler one, comparing to the problems I have done today. Okay, so this one you are familiar with. So what we have is an op amp. It's not an ideal op amp that has a gain of 10 power 4 and input impedance of 10 mega ohm and output impedance of 100 ohms. And this op amp is used to under the unity gain feedback configuration as a voltage buffer. You know what exactly the equivalent circuit is. Then the closed loop output impedance of the op amp in the circuit is okay. That means what is the configuration given? So we have op amp with a gain of 10 power 4. So the configuration is this. That's your op amp first. Input resistance is given 10 power 4. Its voltage gain is given. This is the VD, non-inverting terminal, inverting terminal. Let me take it as a ground. So this is going to be A0 into VD. What is A0 given? Okay, 1 minute. What is the input impedance given? 10 power 4 is given. So gain is given as 10 power 4. So it is going to be 10 power 7 ohms it is. And this is 10 power 4 into VD. That's a open loop gain. And we have the output resistance. How much? 100 ohms given. So this op amp under the influence of negative feedback. The feedback is unity. So where the output is connected, this is your output V0. And this is where the input is given. So V in simple op amp buffer. And here we have the connection. So this is the connection. So this is your feedback. Beta is equal to 1 straight away. Okay, you mentioned unity gain feedback. So beta is 1. A0 is given. A0 of op amp is 10 power 4. Then we are looking for the output resistance under the closed loop condition. So what is the output? Voltage output. If we connect a load, what it is looking for? The output resistance to be equal to ideally 0. So if you have a closed loop equivalent, so this is your R in CL, this is your V in, so it's your R in CL. So it is sensing your input voltage. So therefore R and CL should be ideally infinity for a voltage sensing. And similarly, this is the closed loop gain ACL into Vin. And this is going to be R0 CL. Okay, if we reduce the overall closed loop structure into this box. Okay, so what is expected is the output is a voltage source, input is a voltage source. If you want to sense a voltage source, the input resistance must be infinity. Then as per the practical voltage source equivalent, always we expect the internal resistance of the voltage source must be equal to 0. Therefore, R0 CL must be ideally equal to 0. If A0 beta equal to infinity, it will happen. So, but in this case, A0 beta is finite, but ultimately ideal is 0 and practical is divided by 1 plus A0 beta, because 1 plus A0 beta has to decrease your output resistance. So R0 CL is going to become R0 by 1 plus A0 beta. So have your expectation, you know your A0 beta. So A0 is 10 power 4, beta is 1. So A0 beta is 10 power 4. So what is the numerator? It's 100 ohm divided by 1 plus 10 power 4. So don't commit the mistake by adding, okay, by discarding 1. Okay, you can commit small mistake only. So it is not going to result in a huge error. So simply 100 by 10 power 4, 10 by 10 power 4 is going to be 10 power minus 2. So you're expecting the answer is approximately around 10 milli ohms, but go for the accurate solution. The accurate solution R0 CL should be equal to 100 ohms divided by 10,001. Okay, that's again. So 100 by 10,001 will be so, but your answer must be in milliohms rounded off to 1 decimal place. Okay, so 100 by 10,001. Yes, manipulation needed. 10,001 for accuracy of the answer. So it is 9.99999 milliohms, he said. So it's in milliohms. So he said up to 1 decimal places. So if you round off this, then it is going to be 10.0 milliohms only. So the answer must be 10.0 exactly. Okay, yes, that's a simple, interesting problem exploiting the fundamentals of voltage output, voltage series feedback. Okay, simply voltage series feedback. Okay, voltage output, voltage feedback, feedback topology. Okay, so that's your answer. So we'll update you with the next problem soon. Thanks for watching and do subscribe our channel.